All right, our final chapter of the year. It's only 4 days long. We got 6 days left in school, 6 classes left in school, including today. Yeah, there'll be a test in this unit, okay? And there's only like really days 1, 2, and 3 where you learn new stuff. Day 4 is a combination of putting days 1, 2, and 3 all into practice. So, put your name on it. Mr. Dhaliwal, we are block 2 of block 3 of day 2. All right? So, this unit is called trigonometry. All right? The geometry of triangles. So this whole chapter, we're working with triangles. So if you look through the whole unit package there, you'll just see triangles everywhere. All right? And this is one of my favorite things to teach in grade 9 and grade 10. When you go up to MSS, it'll be probably the 2nd or 3rd unit. You start on talking about it when you get into grade 9. And it's really important for this chapter that you have a scientific calculator that has these 3 buttons on it. Sine, sin, cos, pronounced cosine, tan. All right, if you don't have these 3 buttons, this chapter will be a flop for you. I do have a couple of calculators I can lend out, but I do not have enough. So today's class, you don't need the calculator, but starting next class, you will need it. All right? And you guys all should. So when in September I mentioned, hey, what kind of calculator you guys need? I said you need a scientific calculator, and I asked for this kind of thing. So if you don't have it, it's like a $10 calculator. Right? You'll need it for next year anyways. So might as well get one. Okay, now I find this chapter to be the most practical. So I'm going to share a little bit of Mr. Dhaliwal's hobby with you guys. All right. Now, most things in our environment are squares and rectangles. So if you're building and stuff like that, a lot of shapes can be broken down into triangles. So take a square and a triangle, you split it in half. Sorry, a square and a rectangle, split it in half, you get a triangle, right? And you can use the angles and the calculations to figure out missing dimensions. So Mr. Dhaliwal likes to woodwork in the summer. So this is one of my projects that I built a couple years ago. So I made my patio furniture for my deck. My kids are getting older, rambunctious. They break things, so I made something solid, right? So this is my set of furniture I made, right? And let's see. These are the plans I created. So I went online and I found out what is a comfortable seating angle. You want the back to recline, you want the seat to recline so your butt gets sucked into the cushion. So then I figured out for my family what kind of height I should have. And so my wife's shorter, she hates it when her feet dangle, right? So I figured out all the sides, then I used the stuff we're going to learn this chapter to figure out all the angles I need to have and the lengths. And so that's what I kind of cut apart. So I figured out now it looks like a big giant mess, but by the end of this chapter, if you wanted to, you could do that. You could figure out all those dimensions, all those calculations. And let's see. See, this is me working away. So this is one of the biggest projects I had. So I took all those pieces, and this is my construction project halfway around. So put it together. That's what I had, all right? And it comes in handy, right? I like building one summer. We're building a fort for my kids, and it came to put it on the roof, and my father-in-law was helping me build the fort. And so we have a little, just like a lean-to style roof on my fort. Where's my kids' forts? Right here, right? And it came time to put the roof on. You know, some of our babies there. And my father-in-law's like, let's just climb up there with the saw and just cut the angle of the thing. I'm sorry, I don't feel like climbing 12 feet up into the sky here and with a saw cutting down this piece of wood. So it took me like less than a second. I calculated the angle on the ground, and we just chopped it on the ground and we put it up the wood. It just fits. So if you know how to do this, you can sort of get around some tricky situations, right? So I'm not sure if you'll use it, but it's a very practical skill to have. What do you make? What?
Nothing. I was just thinking about my dad when he wants to build a chicken coop, except he couldn't figure out how to figure out what the length of the roof was for the triangle. And I had to teach him how to figure that out.
Yeah. So it comes in handy in so many ways. Like you're gonna grow up, you're gonna have houses, and you want to build it. Like another reasons for my patio thing was, hey, my deck isn't super big, and so I wanted to optimize the space, right? We used to have a patio table, and the kids could be kind of close to the edge; it would fall off. So I wanted to customize it to fit the space perfectly. So you can do that, all right? Right? Some of you guys are probably more into doing that right now. Some of you guys might be in the future, all right? But you guys will have the skill. Okay, so today we're not going to talk about the calculations. Today we're going to learn out how to set up the equations. All right, and there's 3 equations that you need to know, and they're highlighted in these boxes here. There's a sin one, is pronounced sine. There's a cos one, that's pronounced cosine. There's tan, that's pronounced tangent. Okay, so in order to use these equations, you need to be able to label the sides of the triangle. And you did a little bit of that last year, right? And you don't have to memorize these. I will give you these. And we have a little saying here, which I'll talk about in a moment. But by the end of this chapter, you will have it memorized. So going back to labeling. All those equations requires your ability to label the sides of the triangle. Right? Now, last year, this long side over here, across from this box. What did this box mean?
So it looks like if it's a right angle.
A right angle, 90 degrees. So these equations that we're talking about today, or in this whole unit, only works with right angle triangles. So the corner is 90 degrees, and the longest side is always across from it. What was that side called? Do you guys remember that? Started with the letter H.
Hypotenuse.
Hypotenuse, right? So I'm going to write down HYP, right? So now in our notes here, I'm going to say the longest side is side AB. So we're going to have letters around the triangle, and we have in each corner we have letters. So the side AB is between the letters A and B, right? And this is called a hypotenuse. HYP OTENUSE. Hypotenuse. Okay. Now there's 2 other sides of the triangle, and last year there was generic names that we gave, and they were called. Most teachers call them like legs, right? And we used it in the Pythagoras formula because it didn't matter what side was A, what side was B. You can mix it around. This year it matters what you call each side. Okay. Now, the sides. There's 2 other sides. One's called adjacent. The other one's called opposite. And it really depends on which angle you're talking about, referring to. So here, in this question, if I want to figure out or work with this angle here, we have to label the sides according to this angle. Hypotenuse is always the hypotenuse. It's across from the 90 degrees to the longest side. The other 2 sides depends on which angle you're talking about. There's an angle here and there's an angle there. So let's talk about this angle here. All right, the side that is next to the angle that you're looking to, it's called adjacent. Adjacent means next to. So this is called adjacent. Okay? Or maybe I use letters A, D, J. So the side next to our angle, that's BC, is called adjacent. Okay? Then the other side, the one across from our angle, so going all the way across, here's an angle going across from it here, so that's side AC. That one's called your opposite. Okay, it's opposite my angle, this side. Okay, so there's three sides you need to build a label: hypotenuse, opposite, adjacent. Hypotenuse is the longest side, adjacent is next to whatever angle you're working with. Opposite is the one across from your angle.
So it depends on where
Depends on the angle you're talking about. So these two.
So that's just like the label of the angle?
No, label of the side. So here, oops, should be in orange, and we'll go OPP here. All right. So it depends on which angle we're working with. Okay. Well, we'll do more work with it. Okay. So let's go over here. All right. So here is my angle X. Okay. Practice labeling. What side is your hypotenuse? So always start with your hypotenuse first. Is it LM, MN, or LN? Which side is your hypotenuse? LN, all right? So I'm going to write down HYP here for hypotenuse, right? It's across from the 90 degrees, the longest side, okay? Next, which one is your adjacent? LM or MN? Caitlin? No. Right? Here is my angle. What side's next to it? Yeah, this one, this touching it, it's right there, right? So this one is my adjacent side right here.
Oh, I thought we were doing opposite.
Oh, okay, sorry. Okay. All right. Now, I didn't say this, but the way I've been saying the sides, LM, NL, MN, when we say it, I'm not going to mark you wrong, but we say it like in alphabetical order. So I say MN, not NM, right? That's just like a math little convention. So that means the leftover side, the one across from here, is our opposite. So this is your opposite. Okay. All right. So let's do this again. All right. I'm going to highlight the angle I'm working with. Start off with your hypotenuse. Which one is our hypotenuse? TU. Across from the 90 degrees, the little box points to your hypotenuse. The corner of it points to your hypotenuse. So it goes over here. Hypotenuse, HYP. Okay. Adjacent. Which one's adjacent? Caitlin?
SU?
SU, right? So here's our angle that we're working with. That's the side right next to the angle, because the other one's already labeled. So this is our adjacent, ADJ, and we have opposite here. That's it. Right? You can label it, then you can start using the equations. So there are 3 equations. Okay? All right. So like I said, you don't have to memorize these. I'm going to put these on the board after our class. It's going to live on top of the board for the rest of the year. So it goes sine. This little symbol here is theta. It means our angle. This means sine of your angle is your opposite side over your hypotenuse side. Cosine of your angle is your adjacent side over your hypotenuse side. That's our formula. And finally, tan of our angle is our opposite over adjacent. So we're just setting up fractions each time. And our calculators have these kind of buttons in here for that. All right, now, to help you memorize those, even though you don't have to memorize it, we have this catchy phrase. I don't know why. It gets stuck in it. You go home, you tell it to your parents, chances are you're going to remember this. So this here is pronounced Sakatoa. Okay? It helps. I don't know why, it gets stuck in your head. I crossed the border a couple of years ago, and sometimes the border guards ask you weird questions to kind of verify who you are. All right? And so I was crossing the border, and he's like, "Oh, what do you do for a living, Mr. Dhaliwal?" "Oh, I'm a teacher," right? And then he's like, "Oh, what kind of teacher?" "Oh, I teach math and science." The only thing he could remember to question me about, he goes, Sakatoa. I'm like, yeah, that's right. He's like, go ahead. Right? It gets stuck. So the way this works is the S stands for sine. The equation for sine is opposite on the top, hypotenuse on the bottom. Opposite over hypotenuse. Cosine of our angle is adjacent over hypotenuse. Adjacent on the top, hypotenuse on the bottom. Right? Tan of our angle is opposite on the top, adjacent on the bottom. So it goes up, down, up, down, up, down. Right? So eventually you'll have this memorized. It's a weird one. It gets stuck in your head, Sakatoa. And that's our equation. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. Okay, so we're going to set these up. Okay, so going over here. Here is our angle. All right. Label the sides of the triangle. Which one is our hypotenuse? 5, 12, or 13? 13. Now, we don't need to write down the whole word hypotenuse or HYP. You'll start writing down abbreviations. We'll just say H, and I'll put a little circle around it. So that's my hypotenuse. Okay?
So would 12 be adjacent then?
Then 12 would be adjacent. Here's my angle. The side next to it is 12. That is my adjacent. So I'm going to put it down like A. Colin, you taking some notes here, bud? Right. Yeah. That means the 5, the side that's left over, is our opposite side.
12 was a place.
It's a place?
I thought it was.
No? You've heard of it before.
Yes, but
Yeah.
I thought it was a place.
No?
I'm pretty sure it was in some movie somewhere.
All right. Okay, so now I want to set up the equation. So we go sine, we don't say sine of theta, sine of our angle. So in this question, our angle is labeled with x. So we go sine of x is equal to our opposite side over hypotenuse side. That is the equation that we're given. You won't be asked to memorize it, but you will know it. So we want to fill out this. Sine of our angle. Then we have a fraction. Opposite side is 5. Hypotenuse side is 13. So it's 5 over 13. That is your sine of your angle. Okay, Layla, you can sit down. Here you go. Layla. Good one, right? Okay. Cosine, next one. Cosine of our angle is called x here, is our formula is adjacent side over hypotenuse side. Okay, so cosine of our angle, what number do we put on the top of the fraction? What number do we put on the bottom of the fraction? Caitlin?
Top's 12, bottom's 13.
Top is 12, bottom is 13. Adjacent on the top, hypotenuse on the bottom. Right? Finally, last one. Tangent of our angle, and that's our opposite side over our adjacent side. So I'm going to write that out. Tan of our angle. Zooming out a little bit. What number goes on the top of the fraction? What number goes on the bottom of the fraction?
5 over 12.
5 over 12. Our opposite side on the top, adjacent side on the bottom. 5 over 12. So we have 3 equations. These are the only 3 equations. Maybe Pythagoras will throw in there as well. We'll be using. And you've learned how to set it up. So you just got to learn how to use these equations, which will be day 2, day 3 notes. All right? Okay, so going back over here. Let's do this one. All right. Let's see if you can do it yourself, actually. Step 1. Let's just do the top one. All right? This one here. Label the 3 sides of the triangle. Start with hypotenuse first. Which one is your hypotenuse? Which one's your adjacent? Which one is your opposite? All right? Start with hypotenuse first. Okay? That's correct. Now, which one's adjacent, Natalie? This is your angle. Adjacent means next to. So what side is next to it? No, next to your angle. This is your angle here. So you have 34 and 16. 34 is already labeled, right? 16. Okay? Then that leaves that one. Yeah. Okay. Adjacent, opposite. Good. Which one's your hypotenuse? Yeah, because it's carrying off here. You're going to come over down. You can write down all of it. You can do this question, you can do this question. I can't help you if you're not participating. Right? You have a role here. Okay, you've labeled them all correctly. Now set up your equation.
So do I have to write the number?
No, just write the fraction.
Can I just write it?
Yeah, just write the numbers for your fractions here. All right? So, I've talked to a few of you guys. Most of you guys have it set up correctly. This is your hypotenuse. This is your adjacent side. This is your opposite side. So now, write out the three equations. What's your number on the top? What's the number on the bottom? Flip back to page 1. Hypotenuse sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Right? So you go over here. That's okay. Opposite over hypotenuse. So opposite is 30. Opposite is 34. 34, 34. Okay? See what this is? Okay. Yep. That's right. Now you want to set up your equation. Do the numbers. What numbers on the top, what numbers on the bottom. All right? Okay. Your formula is not right. It's opposite over hypotenuse. All right? To double check you have it the right way around. All right? So, sine is opposite over hypotenuse. So 30 over 34. Cosine is adjacent over hypotenuse, so 16 over 34. The order of these matter. Tan is opposite over adjacent, so 30 over 16. Okay, I'll do one last question with you guys together, and I'll give out the assignment. Okay, let's do angle X first. Okay. According to angle X, we start off with our hypotenuse. What side is our hypotenuse? 3, 4, or 5? 5, the longest side across from the 90 degrees, so that gets an H. Now, we got a 4 and a 3 left. Which side's your adjacent, the 4 or the 3?
3.
Adjacent is the 4. Next to the X. Across from the X is your opposite. Okay? So next up, setting up the equations. Sine is opposite over hypotenuse. So what number's on the top? What number's on the bottom?
3 over 5.
3 over 5. Cosine of your angle is adjacent over hypotenuse. So what's your fractions? What's on the top? What's on the bottom? 4 over 5. Okay? So now, the second part of this question says, what are the formulas for angle Y? Well, if we're now talking about a different angle, our labeling changes. Right? So if we're now talking about this angle here, according to angle Y, our hypotenuse still stays the same because that's the longest side. That doesn't change. But what's now your adjacent side? to the 4 or the 3?
Jason would now be free.
Now that adjacent side would be over here. Because this is now the side that's next to it. So that's your adjacent side. And the one across from it now becomes the opposite side. So these formulas are dependent on which angle you're working with. So if you're now talking about angle y, well, that's the one across from it. That's the one next to it. All right? So going over here, our sine formula, and this time a tangent formula. Sine, opposite over hypotenuse. What's the fraction?
4/5.
4/5. Tangent is opposite over adjacent. What's the fraction? 4/3. Okay? So today's assignment is just labeling the sides of the triangle and setting up these fractions. All right? So I made a mistake when making the